In 2021, a single Ethereum transaction during peak congestion cost $50 to $200 in gas fees. Developers were building applications on infrastructure that charged more per transaction than most users could justify for routine interactions. In 2026, the same transaction on a Layer 2 network costs a fraction of a cent. The infrastructure changed, not the underlying Ethereum blockchain. That change is Layer 2 scaling, and it is now the dominant architecture for how Ethereum actually gets used. Why Ethereum needed a Layer 2 Ethereum mainnet processes roughly 15 to 30 transactions per second. Every node in the network must process and store every transaction, which is what gives Ethereum its security guarantees. But it also limits throughput. The solution is to move most transaction execution off-chain while keeping Ethereum as the settlement and security layer. Layer 2 networks execute transactions in bulk, compress them, and post a summary back to Ethereum. Ethereum verifies that summary rather than each individual transaction. The result is higher throughput, lower cost, and the same security guarantees as Ethereum mainnet. Optimistic rollups assume valid. Challenge if not optimistic rollups batch hundreds or thousands of transactions and post them to Ethereum with a simple assumption. All transactions are valid unless someone proves otherwise. Anyone can submit a fraud proof during a challenge period, typically 7 days, if they detect an invalid transaction. This design is simple and compatible with existing Ethereum tooling. Developers can deploy their existing contracts to an optimistic rollup with minimal changes. Transaction costs drop dramatically compared to mainnet. The main limitation is the withdrawal delay. Moving assets back to Ethereum mainnet takes 7 days, while the challenge period expires. Fast liquidity providers can accelerate this, but they introduce additional trust assumptions and fees. ZK rollups, prove it with math, zero-knowledge rollups take a different approach. Instead of assuming validity and waiting for challenges, they generate a cryptographic proof that all transactions in a batch were executed correctly. This proof is posted to Ethereum alongside the transaction data. Ethereum only needs to verify the proof, not re-execute the transactions. Verification is fast and cheap. Finality is immediate. Once the proof is accepted, there is no challenge period and no withdrawal delay. As of 2026, ZK technology has matured to the point where proof generation is near instantaneous for most transaction types, removing the last major practical limitation of this approach. ZK rollups now offer better finality guarantees than optimistic rollups with comparable throughput and cost. What the Ethereum Dencun upgrade changed in March 2024, Ethereum introduced blob transactions through EIP 4844. Before this upgrade, rollups posted their transaction data to Ethereum call data, which is permanent and expensive. Blob data is cheaper because it is stored only temporarily, long enough for fraud proofs or ZK verification to complete. The result was immediate. Layer 2 transaction costs dropped by approximately 90% within days of the upgrade. Subcent transactions became routine across the ecosystem. The economics of building user-facing applications on Ethereum shifted permanently. The L2 ecosystem in 2026 Layer 2 networks collectively hold over $45 billion in total value locked and process more transactions daily than Ethereum mainnet itself. The ecosystem has diversified. Rather than one dominant rollup, there are dozens of specialized networks, each optimized for specific use cases like consumer apps, DeFi, gaming, or compliance-sensitive finance. The question in 2026 is not whether Layer 2 works. It works. The questions are which rollup architecture best fits a given application, how cross-rollup interoperability evolves, and whether the fragmentation of liquidity across many L2 networks creates more problems than the scaling gains solve. Conclusion: Layer 2 scaling solved the problem that nearly killed Ethereum as a platform for everyday use. The path from $200 gas fees to subcent transactions was not inevitable. It required years of cryptography research, protocol engineering, and coordination across the ecosystem. If you are building on Ethereum in 2026, you are building on Layer 2. Understanding the difference between optimistic and ZK rollups, their trade-offs, and their current limitations is foundational knowledge for anyone working in this space.